Okay, so let's begin with the revision of our chapter Electrostatics. So let's start with the question number one. So the question number one, part A, is actually asked for the statement of the Coulomb's law. So based on the previous video, we discussed about Coulomb's law is actually discussing about electrostatic force. Electrostatic force. So hence the Coulomb's law, Coulomb's law actually states that the electrostatic force, so remember there must be a subject, the electrostatic force exerted between two point of charges is directly proportional to the product of the two charges. Okay, this is the product of two charges and is inversely proportional to the square of distance between them. So this is basically is the statement of the Coulomb's law, which states that the electrostatic force exerted between two points of charges is directly proportional to the product of two charges. So this is charges, and is inversely proportional to the square of distance between them. So this is qualitative explanation. So as for the formula, which is quantitative, the F is actually directly proportional to the product of the two charges, which is Q1, Q2, or you can write it in terms of capital letter, which is better. So is inversely proportional to the square of distance between them. So this is R squared. Okay, so this is the statement for the Coulomb's law. So the Coulomb's law is actually quite similar to the definition of, not definition, sorry. It's quite similar to the statement of Newton's law of universal gravitation, which stating the gravitational force. So the difference between these two forces is actually the gravitational force is actually describing the product of the two masses. As for the Coulomb's law, the electrostatic force is actually describing the product of two charges. So that's the difference. Okay, so we have done for part A. So let's proceed to part B. So part B, the figure below shows the arrangement of 3-point charges Q1, positive 5 nano coulomb. So Q1 is actually 5 times 10 to the power negative 9 coulomb. As for Q2, positive 10 times 10 to the power negative 9 coulomb. And Q3 is 5 times 10 to the power negative 9 coulomb. So this is the charges. So this is the diagram. Okay, and this is Q2, Q1, Q3. So find the net force acting on Q2. So the question is actually mentioned about Q2. It means that our main focus is actually on the charge Q2. Okay, so before that, before we calculating the magnitude, we need to know that what is actually the direction of the forces that exerted on Q2. So first of all, okay, let me just write it down. Okay, so first of all, we know that this is Q2, so and this is Q1. So since both of them are the positive charges, it means that Q1 and Q2 is actually repelling. So they are actually repelled to each other. So I can finally say that, okay, let me just erase this Q2. So this is Q2. So finally I can conclude that my F21 is actually pointing this way. So this will be my F21 since both of them are repelled to each other. So this F21 is actually in inclined form. Okay. So as for F23, so since both Q2 and Q3 are actually positive charges, and hence they are also repelled to each other. So okay, let me just draw it properly. So I can conclude that my F23 is actually in this way. So this is F23 and this is F21. So both forces is actually in the form of inclined form. So what we need to do is actually find F2. So F2 basically is actually this one in the middle of F23 and F21. So this is F2. Okay, so I can conclude that this F2 is actually okay, so let me just explain it one by one. So this let's say this is F23. So since this F23 is actually in inclined form, so this is inclined, or I can say it is a not steep. So by the way, it is inclined form. So this is inclined form. It means that this F23 is actually in the form of resultant force. So we know that resultant force is actually consists of two components, which is vertical component and horizontal component, which is Fx and Fy respectively. So this same goes to F21. So this is F21, of course. So F21, which is also the inclined form. So this F21 is actually a resultant force. So this resultant force will eventually give us the vertical component and horizontal component, which is Fx. So now the question that requests is we need to find out what is F2. So since there are two vertical forces acting on this Q2, which is this one and this one. So finally, I can conclude that my F2 is actually equals to the F23, the horizontal, the vertical component, plus, okay, so, okay, let me just write it more accurate. So this is F23, so what we need is the vertical component of the F23. So my vertical component is actually F23 sine theta. So plus the F21 sine theta as well. Okay, so in this case, okay, so based on the diagram, so in this case I can conclude that, so this is my F21, so this is my F23. So this is actually my theta. So since the theta is not given by the question, so hence we need to find out ourselves. So based on the theorem Pythagoras, so 3 squared plus 4 squared is actually 5. So this is the 5 millimeters. So same goes to this one, which is 5 millimeters. Okay, so 5 millimeters. Okay, so we know that. So let me just drag it to right. Okay, so we know that sine theta is actually equals to the opposite divided by hypotenuse. So opposite divided by hypotenuse is actually 3/5. So I can conclude that my F23, so this sine theta is actually 3/5 plus F21 3/5. So what we need to do is actually calculate the magnitude of F23 and F21. So obviously the Q1 and Q3 is actually the same. So the forces, the magnitude for Q1 and Q3 is actually the same. So the forces is actually both forces which is exerted on Q2, the magnitude are the same. So this is, let me just calculate in another equation. So this is F23 of, or F21. So K Q1 Q not Q1, sorry. So this is Q2. The main our focus is on Q2. So this should be Q1 or Q3 since both charges are the same. So the distance between two charges on Q2 is actually the same as well. So my K is actually 9.0 times 10 to the power of 9. So my Q2 is actually 10 if I'm not mistaken. Is it 10? Okay. So this is 10 times 10 to the power negative 9. So Q1 or Q3 is actually basically is positive 5. So 5 times 10 to the power negative 9 divided by, so based on Pythagoras theorem, so what we get for this hypotenuse is actually 5 millimeters. So this is 5 times 10 to the power negative 3, and this is square. So the final answer that we get is actually 10 times 10 to the power negative 9, 5 times 10 to the power negative 9 divided by 5 times 10 to the power negative 3 square. So the magnitude for F23 or F21 is actually 1.80 times 10 to the power negative 2 newtons. So hence we can find out what will be our F2. So my F2 is actually equals to the 2 times, so if we factorize this 3/5, so what we get is actually 2 times 3/5 times 1.80 times 10 to the power negative 2. So this 2 is actually the forces for F23 and F21, since the magnitude of F23 and F21 are the same. So I directly As for another formula, okay, so as for another formula, so what we have is actually equals to EA. So in this case, there are two conducting plates, and hence the conducting plates consist of two surface area. Okay, so this is A plus A. Basically, what we get is actually E2As. So this is the concept of uniform charge conducting plates, which consists of two plates. Okay, so let's just move on to question B. Okay, let me just, oops, okay. Can I just drag it up a bit? Okay, so let's begin with question B. So this is still question number 2. A charged particles of, so my charged particle of 40 mu coulomb, so mu is actually times 10 to the power negative 6 coulomb. So it's placed in a uniform electric field. Okay, so it's placed in a uniform electric field of, okay, so my electric field is equal to 2.82 times 10 to the power 5 nano per coulomb. So let me check the magnitude whether it is correct. So yeah, the magnitude is correct. Force exerted on the particle. So the force so what we need to apply the formula, which is F equals to EQ. So my E basically is 2.82 times 10 to the power 5. So my Q is actually 40 times 10 to the power negative 6. So this is the answer. 2.82 times 10 to the power 5 multiplied T times 10 to the power negative 6. So the final answer what I have here is actually 11.28 newtons. So this is the part 1. As for the part 2, the work which is required to move the charged particle to a distance of 5 cm against the direction of electric field. So based on usually the work done that we write is actually the QV. Q multiplied by the potential difference, electric potential difference. So in this case, the electric potential difference is not given. So this formula is actually not applicable. So insteadly, the question is actually given the distance which is work is done in this distance, which is again the direction of electric field. Okay, so the work is basically is Fs. F is the F which is a product of the displacement. So what I have is the electrostatic force. So the electrostatic force multiplied by the distance, -2. So what I get is 0.564 joule. So this is how we find the work done given. So the formula that we need to apply is the basic formula for the work done. Okay, so let's just proceed to question number 3. Okay, let me just erase all this one. Alright, so let's move on to number 3. Let me just drag it down. So, okay, so question number 3. So the figure shows 4 points of charges Q1, 5 nanocoulomb, Q2 column, Q3 5 nanocoulomb as well, and finally Q4 is -5. So find the electric field strength at the center of the circuit. So before finding the magnitude of the electric field strength, we need to determine the direction of electric field strength on the the field strength exerted on Q2 is actually this way, which is actually the positive charge. Okay, Q3 is alright. So Q3 is actually the positive. So the positive is pointing upwards. Since the electric field is pointing outwards from the positive charge, is pointing upwards. Okay, so this is my E3. So as for the E4, so uh, charge. So negatively charged is that the inwards towards the point charges. So this will be my E4. Okay, so after determine the direction of the electric field. Okay, so since we can see the magnitude of the 4 charges is actually the same, so I can conclude that my E3, so since the one are in opposite the negative E1 is equals to the E3 minus E1. See? So this negative is actually indicates the opposite direction of E1. Okay, so this is my Q3 over R square. So this is KQ1 divided by R square. Of each charges, so I can conclude that E3 minus E1 is equals to 0. This is the electric field strength exerted on the point, the vertical electric field, vertical E. So what about the electric field strength which is acting horizontally on the point at the center of the circle? So since the E2 and E4 are in the same direction, so I can E2 plus E4. So this is KQ2 for R square plus KQ4 square. So finally, I can write it in terms of 2 times the 9 times 10. Oh, sorry, this one. So Q4 is actually 5 times 10 to the power negative 9 divided by my R square. So my R square, which is the radius from the center of the circle. So this is the 30 times 10 to the power negative square. So answer. So the electric field strength, which is okay. So the electric field strength exerted at the center of the circle is actually 1.00 times 10 to the power of 3. So this is Joule. Sorry, not Joule. Okay, so SI unit should be the Newton per Coulomb. So this is the electric field strength. And the electric potential. Okay, so find the electric potential at the center of the circle. So let me just erase this one. that. Okay. Okay, so I think this will be the last question. Yeah. All right, so let's move on to question number 4. So define the electric field strength and electric potential. Okay, so electric field strength is actually defined as the force per unit charge acting on that point. So the electric field strength is defined as the force per unit charge acting on that point. So that point is actually shows the one of the point which is inside the region of the electric field. Okay, so this is electric field strength. As for the electric potential, so electric potential is defined as the work done to um, move a unit charge from infinity to that point. So electric potential is actually defined as the work done to move a unit charge from infinity to that point. So same goes to this statement, which is that point is actually meant by a certain point in the region of electric field. Okay, so that's it for the question number 4a. Okay, so let us just proceed to part B. Alright, so this is part B. So sketch the electric field and the equipotential of a negative point charge. So this is negative point charge. So electric field, so let's say I have a negative point charge. So this is the charges. So we know that the electric field lines which exerted on the negatively charged. So the electric field lines is actually always pointing inwards towards the center of negatively point charge. So this is the electric field. Okay, so all the lines are actually inwards. Alright, so this is the electric field lines. So as for the equipotential surface, so let's say this is the negatively point charge. So this one will be the equipotential surface. So the equipotential surface consists of different layers. So this is the second layers, and this one will be the third layers. So we know that the electric field lines is always perpendicular to the equipotential surface. Okay, so the electric field line is not necessary. So this one will be the equipotential surface. So if you wish to draw it for one surface, is actually also acceptable instead of many surfaces. So let's say so this one will be the equipotential surface for one surfaces only. Alright, so let's just move on to part C. Alright, so this is part C. So let me just drag it down. Okay, so part C. Point charges Q1, Q2, and Q3 are located at the vertices of the equilateral triangle. So the equilateral triangle, it means that the angle of here is actually the 60, and here is 60, and here is 60. So given that the Q1 is actually equals to the positive 45 mu column. As for the Q2 is actually negative 12 mu column. As for the Q3 is actually positive 18 mu column. Oops, sorry. So this is the Q1, Q2, and Q3. So determine the magnitude and the direction of the electrostatic force on Q2. So our main concern is actually Q2. Alright, so before that, we need to know the direction of all forces acting on Q2. So let me just draw it in another diagram. So let's say this is Q2. So between Q1 and Q2, okay, so since Q1 is positive and Q2 is negative. So it means that the both charges is actually attractive. So I can say that my F21 is actually pointing this direction. So this is F21. Alright, so between the Q2 and Q3, so since both of them wait, let me just observe. Oh, sorry. Okay, so since Q2 and Q3 are different charges, and hence both of them are attractive to each other. So my F23 is actually pointing this way. F23. So this will be my F23. Alright, so what we need to do is actually find out the resultant force. Okay, so this is part 1. Okay, let me just think about it. So the resultant force, and what will be our resultant force here? Okay, and the question given is actually 60. And this is the 60. And this will be the 60. So the resultant force is actually in okay, so let me think for a moment. So where will be the resultant force? Alright, so okay. So if I'm not mistaken, the resultant force should be okay. Let me just think about it. So this is F23 and this is the okay. So this F23 is actually in the horizontal form. So this is the Fx. Alright, so okay, so I think I got the idea. So let's go through step by steps. So based on this diagram, what we need to do is actually find out the horizontal component. Horizontal components. So in this case, F23 is already in horizontal form. So the problem is the F21. So F21 is a resultant force which consists of horizontal component and vertical components. So what we need to do is find out the resultant force, the horizontal force for F21. So the horizontal component, the horizontal electrostatic force is actually the F23 plus the F21 cos theta. So this is F21 cos theta. So our theta basically is 60 degree. So F23 will be KQ2 Q3 divided by R squared. So this is R23. So as for the okay, so the distance is not given. Oh, the distance is given. So this is 3 meter and this is 3 meter and this is 3 meter. So the side is actually the same since it is an equilateral triangle. So plus the KQ2 Q1 divided by R squared. This is cos 60 degree. So this is 9 times 10 to the power of 9. So let me just drag it down for a bit. So what will be our Q2? So remember that the negative sign is actually not required for the forces, times 10 to the power negative 6. As for the Q3, it's actually positive 18 times 10 to the power negative 6. So divided by r squared, so this is r squared, which is 3 meter, plus the 9 times 10 to the power of 9. So this is 12 times 10 to the power negative 6. So this is the Q3. Okay, not Q3, sorry. Should be the Q1, 45 times 10 to the power negative 6. So divided by the 3 as well. So here what we need to add is actually cos 60 degrees. So because the one that we need is actually the horizontal component for F21. So what we get for the Fx of 9, 12 times 10 to the power of negative 6, 18 times 10 to the power of negative 6 divided by 3 squared plus 9 times 10 to the power of 9, 12 times 10 to the power negative 6, 45 times 10 to the power negative 6 divided by the 3 square, and this is cos 60. So this will be 0.486 newtons. So this is the horizontal force of the resultant force. So this is Fx. So what about the Fy? The vertical force which acting on Q2. So the vertical force obviously consists of only one force. So Fy. The vertical force exerted is only the forces which came from the F21. Since the F21 is the resultant force, itself is a resultant force, so it will divide it into horizontal and vertical. So as for the F23, so the F23, as I said just now, is already in the form of horizontal, so the vertical force for F23 is actually 0. So my F21, the vertical force for F21 is actually the F21 sine 60. This will be the vertical force. Okay, so my KQ2 Q1 divided by R squared sine 60. Okay, so this is 9 and Q2 is 12 and Q1 is 45 and the distance is actually 3. So this will be the sine 60 degrees. 9 times 10 to the power 9, 12 times 10 to the power negative 6, 45 times 10 to the power negative 6 divided by 3 square, and this is sine 60. So this is 0.468, 0.468, and this is Newton. Okay, so we have the both horizontal force and vertical force. So what we need to do is find out the magnitude of the resultant force. So the magnitude of the resultant force, which is F2, is actually equals to the square root of fx square plus fy square. So the fx 0.486 square plus the fy 0.468 square. So 0.486 square plus 0.468 square. So what I get for final answer is actually 0.675 newtons. So is it correct? Okay, so yeah, correct. So after finding the magnitude and the direction is actually quite important as well. So what we need to do is actually find out the direction. So tangent is actually equals to the fy divided by fx. So what will be my fy? This is 0.468 divided by 0.486. So okay, so my theta basically is 0.468 divided by 0.486. So this is 43.9 degree above x-axis. Okay, so based on the graph, and this one will be my fx, and this one will be my fy, and this will be my f2. So this f2 is actually above the x-axis of 43.9 degrees. So this is how we find out the electrostatic force which acting on Q2. So the solution is quite long. So if we able to understand the concept step by steps, so we are able to find out the answers. Alright, so let's just move on to the final parts. Okay, so this is the final parts. So find the electric potential at the center of point X of the triangle. So basically this is the center, so let me just use another color. So this will be the center. Okay, let me just write here. So since the electric potential has no direction, and hence the electric potential is the sum of the electric potential which produced by the three point of charges. Alright, so the point is we did not have the distance from the center of the triangle to each point charges. Okay, so let me just think for a while. And how should I find out the... Okay, so let me just drag it to the right side. Okay. So let's say this is one of the triangle inside the circle. Okay, so this is the 3 meters, and we know that this is the 1.5, which is the half of the 3 meters. So what we need to do is find out this distance, which is x. So the sine 60, is it sine 60? Sine 60 is actually equals to x. Sine equals to the opposite divided by hypotenuse. So x is basically is 3 sine 60. So in this case, okay, so in this case, alright, so let me just think, is it at the center? Okay, let me just try it out. So the distance is actually 2. So what I get is the distance for the distance from the center of the triangle to its charges. So 3 sine 60 divided by 2, and what I get is actually 1.299 meters. Okay, so I can finally find out the electric potential plus the KQ2 R plus the KQ3. So I'm still not sure whether the distance is correct. So I just tried it out to find. I just test for a while. So if the answer is correct, so that is the solution. So let's just see if, okay, so let's just watch. And Q1 will be the 45 times 10 to the power negative 6 divided by, so 1.299. So my Q2, so the Q2 basically is negative charge, so the negative must be included for the electric potential. 299 and plus 9 times 10 to the power 9. So what will be the Q3? Q3 is the 18 times 10 to the power negative 6 divided by 1.299. So let's see whether it's correct. 45 times 10 to the power negative 6, 1.299 plus 9 times 10 to the power 9. So negative 12 times 10 to the power negative 6, 1.299 plus 9 times 10 to the power 9. So 18 times 10 to the power negative 6, 1.299. So the answer for here is actually, so the answer is quite different from here. So let me just find out where I got wrong. Okay, so I think the distance is actually wrong. So let's just find out where did I got wrong. Okay, let me just erase this one first. So the problem is actually from the distance. Okay, let me just drag it up for bits. Okay, let me just zoom out. Okay, come on. Alright, so the distance here is the problem. So we need to find out where is the, so this actually is a max problem solving. So since this one is the 60 degree, okay, so let me just observe for a while. Alright, so okay. So since this one is a 60 degree, and hence this one shall be 120 degree. Okay. So what I have here is, right, so what I have here should be the 120. So I did not have the value for these two sides, but I have this one. So what will be the formula? Okay, let me just observe for a while. Okay, so this question is quite confusing. Okay, so let me just find it out. Okay, what is actually the distance here? So that's sine 30, 20 divided by... Oh, there's a solution that I found. Okay, so I found a better way to solve this. Okay, so let's begin with this triangle as well. So we know that this one is actually 120. So if we divide it into half, what we get is actually 60. So this one is 60 degree as well. So this three we divided into 1.5 and 1.5. So okay, so let me just see. Okay, so this one, so from this diagram, the degree is actually 60 degree. So this angle is actually 60 degree. So if we divide it into half, so what we get for this one is actually 30. Okay, so based on the solution of the triangle, so what I get is actually the x divided by the sine 30 is equal to the 1.5 divided by the opposite angle, which is sine 60. So what I get for the x is actually 1.5 divided by sine 60 times the sine 30. So this is the 0.866 meters. So the distance from the center of the triangle to the each charges is actually 0.866. So let's see whether it is correct for the electric potential. So okay, we factorize this out. Q2 plus Q3. So let me just drag it down. So this is 9 times 10 to the power of 9. So my Q1 is 45 times 10 to the power negative 6 divided by 0.866 plus, so the Q2 is negative 12 times 10 to the power negative 6 divided by 0.866. So this is 866 plus the Q3. So the Q3 is basically positive 18 times 10 to the power negative 6 divided by 0.866. So finally, what I get, so let's try again. I hope this time will be correct. 0.866 plus negative 12 times 10 to the power negative 6, 0.866 plus 18 times 10 to the power negative 6 divided by 0.866. So finally, okay, so the answer still varies, and I don't know where did I got wrong. Okay, let me just observe again. Okay. So I wonder where did I got wrong. Okay. Times the sine 30. Yeah, the question is correct. So the value should be correct, and I have no idea where did I got wrong. So let me just check the answer. So okay. All right. So let me just observe for a while. And this is 30, and this is all right. So okay, there's another way. Okay, our streaming is actually quite long already, so let's just solve it fast. So, so this is the half triangle, which is from this region that I got, and this one is 60, and this one is 30, and the distance that we need is actually this one, and this is r, and this one is 1.5. So I have no idea why I can't think about this one instead of using the complicated formula. So the cos 30, cos which is equals to the adjacent divided cos sorry cos AH, and is it correct? Okay, not cos, sorry. So this one should be the 30, and this one is sine. Sine 30 equals to the opposite. Alright, not sine, sorry again, my mistakes. So this one should be the tangent. Tangent divided by the equals to the opposite divided by adjacent. So is it R correct? So no, the question is actually quite different, and I have no idea why it's it difference. Okay, so let me just find it out. Okay, I wonder where is the and where is oh okay, so this is the big mistakes. The distance is actually here that we need. So this should be the distance. So what I need is actually the hypotenuse instead of this one. Oh my god. Okay, but it's okay. So what we need to use is actually the cos 30. So cos 30 is equals to the alright is equal to the adjacent divided by hypotenuse. So R is actually the, so is it correct? So this one should be the R. So this one is cos 30 divided by 1.5. So cos 30 divided by 1.5. Okay, so is it correct? I sorry, my mistake again. So is it why is it so confusing about this one? Okay, I'm sorry, my mistake again. So should be 1.5 divided by cos 30 degree. So this is the correct one. 1.732 meters. So this is the correct one. So I'm totally apologize for my mistakes. Okay, so this one is should be the 732. So this one is the 1.732, 1.732, and 1.732. So the final answer is actually, okay, let me just calculate it. 45 times 10 to the power negative 6 and 1.732 minus 12 times, okay, times 10 to the power negative 6, 1.732 plus 18 times 10 to the power negative 6 divided by 1.732. So I hope this time should be correct. Alright, finally. This is positive 2.65 times 10 to the power 5 volts. So this one should be the correct answer. Alright, such a simple question, so it takes too long for me. So alright, that's it for the question and we have done for all the 4 questions. Alright, so the solution is actually, it's look simple, but when writing, for me, it's actually quite complicated. So what we need to do is actually observe it step by step, so that we are able to solve the question more efficiently. So not like just now, which is confusing. For me, it's actually still normal, not quite hard. But as for this one, this diagram is actually totally confused me, and hence we need what we need to do is actually just be careful. Alright, so I think we stop here now. So I'll see you in the next video. So thank you. Bye.